Psyche, a new 2023 mission to the Golden Asteroid. In recent years, space exploration has broken several records, including the New Horizons spacecraft's visit to Pluto, Rosetta's comet touchdown, and Juno's breathtakingly detailed photos of Jupiter. However, plans are being made for new tasks. One of the most intriguing of them is a NASA project that aims to visit the unusual astronomical object 16 Psyche. Bennu and Ryugu, two recent asteroids observed by the OSIRIS-Rx and Hayabusa 2 missions, are not all heaps of stony debris. Some are constructed from tougher materials, such as iron and nickel, which are concentrated in the crowded, hidden centers of worlds. These heavy metal components of our solar system are believed to be leftovers from the cores of long-defunct orbs that were shattered by massive impacts, emissaries from otherwise inaccessible depths of time and space that lie billions of years in the past or thousands of kilometers below a planet's surface. There is no direct way to investigate these crucial planet-building components besides physically visiting such strange objects. The largest metallic asteroid in our solar system, Psyche, is being targeted by NASA for a probe. Scientists may be able to explain the very cores of other worlds, near and far, including our own familiar Earth, by understanding how Psyche formed. However, it's possible that NASA has higher aspirations as well. 16 Psyche, which was one of the first asteroids discovered, the 16th, to be exact, has been known to exist for a very long time. And this, incidentally, explains the significance of the number that, like all asteroids, comes before the name. Beginning with the first, or 1 series, discovered in 1801. Those were the early years of the Great Asteroid Hunt. Today, both huge and small asteroids can be numbered in the hundreds of thousands, although in the 19th century, they seemed to be extremely rare items. The search method involved carefully cataloging stars up to the 14th magnitude, which are 10,000 times fainter than the faintest stars that can be seen with the naked eye. This band of the sky was centered on the plane of the ecliptic, which is where the majority of the main belt asteroids are concentrated. At the time, photographic imaging was obviously not an option because the plates were not yet light-sensitive enough. Instead, the research had to be carried out visually by tracking changes in the positions of some of those light spots over the course of several nights. However, Pallas was discovered in 1802, followed by Juno, 1804, Vesta, 1807, Hygeia, 1849, Egeria, 1850, etc. by European astronomers who mistook it for a race. The 16th was Eunomia in 1851, up until the night of March 17, 1852, when Italian astronomer Annibale de Gasparis of the Observatory of Naples observed a gradual movement of one of those weak lights using a tiny telescope with a diameter of 8.3 centimeters. Following calculations revealed that it was an asteroid, the 16th in the series, later given the designation 16 Psyche, traveling in orbit that was fairly elliptical, averaging 2.9 astronomical units from the Sun. For many years, Psyche and the other planets were just tiny points of light, but as astronomical instrumentation improved, we were able to calculate its size, mass, and other important characteristics. According to what we currently understand, Psyche is an object with an uneven shape and an average diameter of roughly 220 kilometers. An asteroid that initially appears to be normal, then why is NASA getting ready to launch a probe that would eventually orbit this small world after traveling for years? What about up there is so amazing that it justifies launching a mission that costs more than $500 million? Simple. Scientists assumed that more than 4.5 billion years ago, 16 Psyche was a protoplanet equal in size to Mars based on size and mass data from a few decades ago. Between the red planet and Jupiter, Psyche was involved in a series of severe collisions with other huge planetary bodies, resulting in its destruction. 16. Its rocky mantle was torn away, exposing the iron and nickel core. The middle layer was severely impacted by further collisions, and substantial shards were launched into space. Because of the turbulent time during which the solar system formed, when the planets were still forming, the heaviest elements, metals, were tumbling towards the center of the planet. All rocky planets actually have a metal core. Psyche would have all the qualifications needed to be the core of a planet that is no longer there or, more likely, never fully formed. The media picked up the story right away and started to publish articles that focused more on finance than astronomy. They said that the value of such a mass of metal had to be at least 10,000 trillions of dollars. Particularly when new information started to reduce the bulk of Psyche, tales of density also started to mention a significant amount of gold alloyed with other metals. At that time, NASA had the idea to send a probe to closely examine the true makeup of that odd asteroid. But is there any truth to the tale about the enormous fortune that Psyche would conceal? Well, maybe, even if not in the ways that the media has suggested. Okay, we all know how ravenous a monster the global electronics business is. It is sufficient to say that 170,000 tons of rare earth minerals are mined annually, causing significant harm to both the environment and human beings, in order to keep up with the creation of new electrical products, such as smartphones, electric vehicles, batteries, etc. We are also aware of the considerable geopolitical tension caused by China's near-total monopoly on the development of these resources. Aside from iron and nickel, Psyche may include additional metals that are beneficial for the Earth's industrial sector, including gold, platinum, neodymium, cobalt, and other rare materials with a market worth of the trillions of dollars. There are now only a few ideas and conceptual pictures, not actual minerals that could help the developing space mining sector. Additionally, NASA's mission may mark the beginning of a profound revolution. Actually, there's a more fundamental explanation for why a massive golden meteor wouldn't make everyone in the world enormously wealthy. It's because large pieces of metal don't usually produce wealth. It results from the capacity to produce items that satiate human needs. A steel factory is a symbol of true prosperity because it can be used to produce components for vehicles, structures, and other items. Because you may live there or rent it out, a house does too. Even if they are not included in the official statistics, the skills and information you possess are also a sort of wealth. Even a sandwich is valuable as long as it doesn't go bad. A massive asteroid chock full of gold, however, only slightly increases actual wealth. The metal would have many industrial uses and make lovely jewelry and dental fillings, but it wouldn't start a new industrial revolution, significantly lower the cost of products and services, or otherwise significantly improve or make more comfortable human life. Gold doesn't attract high prices just because it is uncommon. Many uncommon items have little to no commercial worth. It's because the demand for it is low compared to how uncommon it is. Furthermore, there is no possibility that a gold asteroid could generate quadrillions of dollars worth of brand new actual wealth because it wouldn't enhance global demand for gold. Once before, something that resembled a golden asteroid occurred. Around 1500, Spain conquered South and Central America and found significant gold and silver reserves. After that, it transported these metals back to Europe where it utilized them to fund military campaigns and other government expenditures. Because gold and silver were utilized as currency at the period, inflation resulted from a decline in the value of money due to the use of gold and silver as money. The value of modern money is not based on the value of gold or any other metal, nor is gold used as money any longer. Therefore, the arrival of a massive golden asteroid would probably not result in an increase in consumer prices, but rather just cause gold prices to plummet to almost zero. However, recent research has partially reduced the amount of metal on Psyche, lowering its average density to 4 grams per cubic centimeter. Although lower than previous metallic asteroids, it is still high enough to raise questions about the exposed core theory. This implies that Psyche must be rather permeable if it is made entirely of metal. Another theory is that Psyche is still retaining at least some of its lighter, rocky mantle beneath her metallic exterior. But why does its surface appear so core-like if that's the case? In summary, there is still a lot of uncertainty because the hypotheses overlap and astronomers have the widest range of viewpoints. On August 2nd of the following year, the Psyche mission will be launched from the Kennedy Space Center's Launch Tower 39A on board a SpaceX Falcon Heavy in order to provide answers to these and other questions, as well as to start investigating the potential for mining asteroids. The probe that will examine Psyche will be roughly the size of a tennis court when its solar panels are fully extended. All onboard equipment, including thrusters, navigation, scientific instruments, and communications, will be powered only by the solar panels. As a result, their surface is quite enormous. In actuality, the shuttle's main body is only little larger than a compact vehicle. This mission will use a solar electric Hall effect thruster, in which electricity produced by solar panels is transferred to an electric rocket engine rather than a chemically fueled one. The first mission to use Hall effect thrusters outside of lunar orbit will be Psyche. Gamma ray and neutron spectrometers are among the scientific tools the Psyche mission will have on board to map and examine the metallic asteroid's chemical makeup. Due to the magnetometer put on board, it will also be able to confirm and quantify the magnetic field, and the two multispectral imagers will undoubtedly produce high-resolution photographs. The asteroid will be reached by the probe in January 2026 thanks to solar electric propulsion and a flyby of Mars in 2023. Once there, the satellite will spend 20 months orbiting 16 Psyche, carrying out its functions from orbits that get closer and closer to the ground. The spacecraft will launch into Orbit A, its first regime, and enter a 700 kilometers orbit for 56 days of magnetic field assessment and preliminary mapping. After that, it will fall to Orbit B, where it will stay for 76 days at an altitude of 290 kilometers and characterize the topography and magnetic field. After that, it will descend to Orbit C, where it will spend 100 days performing gravity experiments and continuing its magnetic field research at a height of 170 kilometers. From everything we have mentioned so far, it should be evident what the mission's objectives are. They must have a thorough understanding of how iron atoms contribute to the creation of planets. By investigating the asteroid's properties, it will be possible to find similarities and contrasts between it and the Earth and the terrestrial planets. It will also be feasible to examine a celestial object with these particularly unique qualities for the first time. On this fascinating asteroid, there are a number of requirements for scientists to be satisfied. They want to know if the small metallic bodies contain the same light elements that are thought to be present in the high-pressure molten metal core of the Earth, as well as whether they are a planetary core or an asteroid made of unmelted material. They also want to characterize its topography, as well as the relative ages of the different regions of its surface. With the exception of a mission extension, the spacecraft will be left in orbit around Psyche for 20 or 21 months, similar to a small moon, on a course that will prevent it from colliding with the asteroid for at least 20 years and most likely for many more. Will this mark the start of the asteroid belt's mining exploitation? What do you think, guys?